I don't make a huge deal about a unit vector, okay? But then Emily brought it to me on the ACT question, and I thought, maybe I should make a bigger deal than I normally do.
It was in the ACT.
It was on the ACT practice problems.
I really didn't.
Okay.
Emily.
It wasn't on the one that you went in Calvary and stuff. I don't know.
Oh.
But it was on
The
one of our practice, something that's a unit vector.
Anyone want chocolate? Anyone want chocolate?
Alright, so a unit vector, like a unit circle, has a radius of 1. Okay? A unit vector, like a unit circle, has a radius or a magnitude, a length of 1. Okay? So, if you want to draw vectors with a unit 1 length, could we draw it right here?
Yes.
And that point would be
0, 1.
or 1, 0.
Oh yeah.
Okay. Oh, I did the parentheses. I didn't mean to. It's a vector. Okay. Or if we wanted to go, sorry to say north south, but go up the y-axis, that could be 0, 1. That's a vector with a magnitude of 1. Okay. They give them letters, I and J. I is always 1, 0. J is always 0, 1. So your X value was the I. Your Y value was the J. Okay? So, if you have a vector that is not unit 1, okay, it doesn't have a magnitude of 1, it's going up like this, vector U, okay, its components, we're going to go over, I don't know, 1, 2, 3, right? So that would be 3I. So 3 times I is what we've gone over. That's 3 units over. Okay? We've gone up, I don't know, 1, 2, 3, 4. So this distance from here to here is 4 times J. Yes, ma'am.
You know how in algebra we talk about imaginary numbers, like with the law? Do those have anything to do with this?
No. That makes me often think of why they use I and J. But they will, and since I saw it on her ACT, I'm going to use those letters.
Oh yeah.
The I and the J. Okay, so the I is the X, the Y is the J, H-I-J. Think about alphabet. Do you know if you've thought about that? The alphabet. X always comes before Y. So that's why you put X, Y. X comes before Y. So I comes before J. Okay? So this is really U. Vector U is really 3I, 4J. They do a plus sign. So if we took, instead of this comma, I forget, because I don't, they do a plus. So if you have a vector, U, that has components of 3, 4, you can also say it is 3I plus 4J. They will call it, what notation is it? IJ form. Bless you.
God bless you.
The unit vector, IJ. And that is all they talk about. That's why I never make a huge deal. There's a little green box about it, and it's less than half a page.
Are you recording?
I am. I started recording before you got here. You were late.
Hello.
So,
I'm sorry I'm late.
If they're talking about a unit vector, you see that I and the J, then it just goes with the X and the Y. Okay?
Wait, can you tell me what is 3i plus 4j again?
It's vector U.
I'm finding the vectors and cross them together. I thought you needed to
You can't simplify.
I thought you knew square root.
I'm not looking for the magnitude.
Oh, that's
I'm not looking for anything else. I
Okay.
mean, I hope you know the magnitude pretty quick.
Yes, I remember.
3, 4, what's that volume? 5. Don't forget those little pieces of information. Don't forget that. So, the last, I really want to get to the end of vectors so that we don't have to be crazy next week. Vectors. If you have two vectors, probably the more important thing is we talked about how to add them. Can we multiply them? Yes. But multiplying a scalar number, multiplying it times an I, times a 1, times a 3, times a fraction even, times a number is easy. What about a vector times another vector? We call it the dot product. It's gonna be, you will use it somewhere. U dot V. Where? I mean, in the real world, nowhere. Vectors, I mean, you're gonna have to know the dot product to find other things that we will use. Okay? An angle, okay, there are two vectors. Okay,
Yeah, two vectors.
there are two vectors, and you want to know the angle between them. You can find the angle of one, the angle of the other one. What if they're all similar and you want to know the angle between them? You can actually use the dot product to do that. The ship is going this direction, the ship is going that direction. What's the angle in between them? Okay, you're going to use the dot product for that. Okay? But it is not as simple as multiplying the x times the x and the y times the y. Okay? If you have vector u dot vector v, they don't put the arrows, I don't know why. Okay? You're going to take each piece, they define vector u as a comma b, vector v as c comma d. So when you're multiplying, you're going to multiply a times c plus b times d, and you will get one number. Okay? So we're going to multiply them, yes. Then we're going to add them together. You're not going to have two numbers. Not in here. Maybe you saw it somewhere else. I don't know. The dot product. So if we have vectors with units, vector v, vector u is 2, -4, and vector v is 5, -3. What is the dot product? Multiply. What?
-6.
-6.
Wait,
Whoa.
no. 10.
22.
Yeah, I was like,
I said 12 plus 12. 12 plus 12 is 24. 22. That is a dot product. Yes, ma'am.
It's just throwing me off the variables. Does that make sense?
You're multiplying this, whatever your x values are, 2 times 5, or your A and your C, and your B and your D, 4 and 3, or -4 and -3.
So the other side is just telling me what you're doing. 'Cause Oh wait, those aren't variables because we already have the.
I have the A and the B. What are you talking about?
The vector u times the.
So vectors, all I gave you was the components. So vector u, here's the components. Vector v, here's the components. Multiply the x's plus product of the y's. You add them together. No. No, we are not going to degrees. That is the dot product. That's a product of when we've multiplied them together. Okay? It's not a visual thing. It's just a thing. You want to go to the geometric interpretation of the dot product. What does it look like? To find the angle between two vectors, we're going to take the dot product divided by the magnitude of both. And that will actually give us the angle between two vectors. What? So, going on with another formula, if you want to know an angle theta, we're going to find cosine theta equals dot product divided by the magnitude. We're going to use cosine. We're non-zero vectors between 0 and 180. Pretending we have vectors. Let's go ahead and draw some vectors.
You just use the same numbers from the last question, like 2 negative 4 and stuff.
I don't know. I was gonna draw some more, but
Let's do a new one.
let's do it.
Use number 7.
Do you want me to use the number 7? Okay. Okay, and this vector.
Number 9.
Let's do one over here. So then let's come up with, this one is vector u, and we're going to say it is 7, 2, maybe?
Sure.
This one is -4, -4. Sure. Can you find the angle between these two vectors?
Yes.
So you're looking for theta right here.
It doesn't matter which one's A, B, which one's C, does it?
No. So what are we doing? Number 1, this is the dot product. We've got to do the multiplication thing. Then we've got to divide by the magnitude of each.
Do you know why?
Because I only have you for 3 more minutes. We don't even have a thought of answering that question. But we can do this one problem. Somebody tell me what the dot product is.
-28
Magnitude of u.
Oh, that means
Add these lines right here mean magnitude. Yes, you need to know that. Is it the square root of 53 total?
No. Just for you times 4 on square root
Okay.
2. Can you leave it on?
I'm going to leave both and then just simplify once. Because
Okay, that makes sense.
because I'm going to do cosine of a decimal. Yes. But yes, it would be 4 root 2. I like that one better, actually. Thank you, Molly.
You're welcome.
So when you get this number, first question is it going to be negative?
Yes.
Does it have to be?
Yes.
What does that mean for cosine of a negative angle? A negative decimal?
It's either going to be a
Okay, so in the second or third quadrant, what do you know then about a number it's going to give you? I mean, it has to be less than 180. It's only giving us a number. It told us theta is between 0 and 180, so it's going to be obtuse. It has to be more than 90 degrees. Alright? So when you plug this in your calculator, what do you get? What decimal?
60.
You already got the angle?
I
I would say it has to be more than that.
it's
It is
-20.
negative 20. Thank you, because I was going to put in 20 immediately too.
So I got 119.
Okay. That sounds much better.
What? Why do I have everything? Look at me go.
Oh, what a negative.
The funny thing is, that was the reference angle in the second quadrant,
Yeah.
but you have to know that. So we got a decimal here. That's a point, negative 0.4856 cosine theta. So theta equals 119 degrees.
Yeah.
Yes,
That's what you got?
I got J. Carson here 5.
Okay. So now, if you have vectors, you can find the angle between two ships that are sailing off into the sunset.
sunset.
Wouldn't you combine those two square roots and just get -20 over 53.4?
Say that again.
Like, couldn't you just multiply 53.4
Sure.
times the square root of 2, and then that would just give you -20 over 50?
I mean, you want to get real crazy? Reduce this. Yes, we want a decimal though. It doesn't matter. No matter what you put in your calculator. Yeah. So really to be 5 divided by the square root of 106. Negative 5 divided by the square root of 106. You got the exact same decimal number. Bye. Have a good day.